operationalize machine learning and artificial intelligence. It's going to be a little technical, but even if you're, a non-technical manager, you should be able to keep up. It's not going to be too painful. We're going to dig into this. This event's being recorded. And let me come over here to my slides. There we go. That's me. I'm Grover Reiter. I'm the chief data scientist here at Zepl. I love working with these applied tool sets. I have a math and topology undergrad, and those of you know who topology know, I spent a couple of decades in the wilderness until Thurston's postulates were finally resolved in 2003. I went to grad school, math, quantum electrodynamics. For those of you who feel slightly intimidated by anybody who went to grad school for QED, think of me as the applied math branch of the family. I'm a plumber. I deal with real world, real data sets. I'm not John von Neumann, and I'm not going to be. So this is supposed to be practical here, and it's not going to get as much into the science, although we're going to touch on that. It's going to talk about how we deploy. I personally am very focused on business or retail data. I've been doing this for a couple of decades. I deal with optimizations, operational optimizations, cost analysis, cost optimization for business data and business streams. I've done some significant work in biogenetics for Genentech. I've done work in epidemiology. I'm doing some work in epidemiology right now, as are a lot of data scientists. I've worked in pharma, finance, but it comes back to the business domain data. And so I'll use some references from business domain data today. By the way, if you have any questions, there's a little question chat panel in the application for Zoom, and you can ask questions, and then Elise will try to alert me. So don't feel bad if you have to ask a question. Here's what we're going to go through today. Basically, what the standard model is for data science projects, the reference progress model. I'm going to put in some real world steps that people don't talk about very much. We're going to look at the big challenges for operationalizing data science, talk about using a proper database, and we'll get into that in a minute. How we collaborate within and with outside the groups, because data science people need to collaborate with each other, but they frequently also need to share some stuff, reporting level stuff, with non-technical managers. You need a way to do that. How we keep secrets secure, how we train and refresh trained models, how we deploy and scale for the right size, and then how we kind of do all this and stay sane using a notebook world. And we'll do some Q&A at the end. So this is the standard model. If you've never seen this, just go Google data science projects, and you'll see an image like this pop up somewhere. I did no invention here. The whole point of this is the way data scientists define how we do things. We got to access and verify the data we've got. We usually have to sample it or subset it. We usually can't eat all of the data that we can access and verify. There is a dirty little secret in data science that we tend to avoid talking about in polite company, which is most data science algorithms require data that can fit in memory for a fair amount of the analysis. But I'm not going to get into that too much. After you've got your data subsetted, you have to clarify it and make sure you understand what it is. Anybody who's been in data science has had the horrifying experience of working on models for 3 weeks, showing up, bragging about what you found, and then having somebody politely explain that you looked at the wrong data, or you excluded the wrong data, or you included the wrong data, or you didn't understand what the mission was at all. And don't feel bad about that. Just clarify that. The thing I always say is, if you've ever heard of carpentry, measure twice, cut once. Verify twice, verify 3 times, verify 5 times, have a final verification before you go public with your finding. Then after you've done some understanding of the data, you usually develop some working models. For people who are not data scientists, they kind of think this stuff is magic, and they think, wow, you're going to use some really cool artificial intelligence that's going to tell me all kinds of things. Well, we actually sample, I just recently finished a project where we sampled 30 different curve fitting models against a data set until we found one that worked. By the way, that model was invented in 1957, so don't get too excited about all this having been invented yesterday. Then after you've got a working model, people then say, hey, I would like, now that you've found cool stuff, I want to deploy it into my business systems, and I want it to scale, and I want it to be wonderful, and I want it to come back and make the thing work. And then there is a typo there, by the way. It's not that thing is operational process. That's wrong. I apologize for that. And then after we've done operationalization, we have to do publishing, reporting, and socialize the data. That is, we have to tell the rest of the business units what's going on here. Now, one of the things you have to do, which is very atypical, if you're not careful, what you'll find is that your data science team was given all the passwords to some critical systems, and they've embedded the stuff right in your code. It gets shoved to GitHub, it's copied across multiple versions, and then finally, somewhere when someone's down to step 5 in this process, they say, I guess we probably shouldn't have the passwords to our most important systems get published to GitHub. Let's take them out of the code. And I'm not kidding, that happens. You can have a code version branched 10 times and still find passwords in it. You have to control the secrets early. We have enterprise data here, it's worth a lot of money, data is the new goal. Figure out how to control the secrets very early. The other thing is, then when you subset the data, a lot of people do a lot of throwaway versions. You know, they haven't kept notes, if you will. Even though we call things data science notebooks, you can't go look at notebook day 1, notebook day 2. We're not using them that way. I recommend we do. I recommend we start naming our versions with progress. I recommend we give proper comments in whatever version control we're using so we can go back and see, this is how I got to here. Particularly if you found negatives or dead ends, keep notes. Say, this notebook shows a dead end. This model did not work and we think it's for this reason. Then the next thing you want to do is, while you're understanding the data, you want to use a proper notebook. And I'll deal in that in just a minute. You want to use a proper database. Then you want to make sure you verified the data, like I said before, and you want to develop a working model. And this is the first time I'll really talk about notebooks, and we'll show you notebook. Probably everybody on this call has seen 20 different notebooks. Fine. If you have, great. We'll show you how we can have an enterprise-grade notebook for data science, which is what Zepl does. We have enterprise, scalable, team-oriented data science notebook tools, but also how you can scale it, how you can then go into production while staying in the notebook model, which is very atypical. And then how we go to live data from historic data, how we build a monitoring dashboard and build a reporting dashboard, all within a notebook environment. That's the whole point of this, is don't leave a nice cloud-based environment. We're trying to deal with quite a few key challenges, and these are big. These are affecting corporations in major ways. Number one is security. Don't kid yourself. Most data scientists use their laptop. They download your most important data onto their laptop. Their laptop gets stolen. They quit. Something happens. You do not have control of your data. So if you're the person who's really responsible for this, I'll caution you. You got to get control of the data, because it's moving all over the place. It's being held on thumb drives, laptops, stray flat files everywhere. This is a serious problem, particularly as you go operational, because your current snapshot data may be super valuable and you don't want anybody else getting to it. You got to get control of the secrets. Scalability. Scaling can be a problem even while you're modeling and testing. One of the things you guys will discover is, and if you listen in at lunchtime, you'll hear people saying, well, I tried to buy a new GPU, but my manager wouldn't approve it. They wanted to buy a GPU to work on a home machine, on your important data, on their home, and for some reason, someone wouldn't approve a GPU, and they can't scale. So they're having trouble scaling even while they're kicking the tires. And you want to detect that early, because they'll go off and they'll buy their own cloud licenses. They'll buy home servers. People will do a lot of things while they're trying to scale. Then at some point, you want to do the opposite of keeping the lid on it. You want to share things. You want to share models. You want to share secrets. You want to share reports, but you want control how you're sharing it. And you want to share it in a way that's intelligent. 1 million branches on GitHub is not sharing. That's 1 million copies. That's not sharing. That's not a team model. Because what you want is round trip collaboration. You want people to be able to work together on models, collaborate, come to a final solution, have a team solution. And then once you deploy them, you want to keep the models refreshed. This is, by the way, a huge error of omission for a lot of people. They train models and then they deploy them, and then they find out later, well, our predictions are getting worse and worse because we're not retraining. And then, of course, reproducing results, version control, and cost management. You don't want this stuff to be an open-ended cost bucket. Okay, first thing, use a proper database. We have a partnership with Snowflake. We're very active with them. They're certainly not the only database we support. And we're going to go look at the product here. That little rabbit hopping at the bottom means I'm supposed to exit PowerPoint and gratefully go to a proper environment and take a look at the notebook. So we'll do that in just a second. It is true that sometimes you'll always have JSON data or heap data or text stream data. For example, if you're using natural language processing, it's probably not going into an SQL database. If you're dealing with a bunch of heap data from IoT devices, it's probably not going into an SQL database. But remember that in data science, the working model is proper square data, data frames, that sort of thing. And that is row column data. And it's really nice if we store the intermediate results in a proper database so that the other team members can see it, it's secure, it's scalable, and you're not dealing with 1,000 copies, you're dealing with a central model. Then when you move from modeling towards production, you need an ETL model for working data and live data. And it would help a lot if you were starting off with a database, because then later on as you move into production, you were already database focused instead of flat file focused or heap focused. And the other thing is a secure hardened database has proven to be the best model for data access, control, security, and scale. At this point, I'll end this and I'll open up a notebook here. I'm going to open up a Zepl notebook here. And for those of you who aren't Zepl pros, I always keep some URLs to get me into the right organization. Here I am in the right organization. And we're going to look at a notebook. So for those of you who are used to just simple notebooks, this is a much nicer interface. It's 100% cloud. So everything I'm about to do is in the cloud. That's a really nice feature set. Now, if we come down here, I'm going to pick one of my little notebooks here, and we're going to go through a couple of drills based on this. So we're going to see a couple of cool features right away. This is a notebook. If you've never seen a notebook, this looks in many ways very similar to a Jupyter notebook. And you can see right here, this is using the Spark and R interpreter. And here I can do a little bit of magic, which is a little hard to support in some notebooks, but works naturally here. I'm just going to change to a Python interpreter. So, and then if I run this, of course, it's actually just saying, hey, my interpreter is Python now. So one paragraph can be Spark or R, another can be Python. You can mix and match a lot of different things. And so I won't go into all those details here. This is real powerful stuff. Then when I come back here, I can do things. And let's take this. Let's suppose I wanted to share this. I want to share this notebook, and I'll show this in a minute. I'll show you how we can share and how we can do things with it. I can set up data sources. So let's talk about a proper notebook. So I'm going to come here to resources, and I want to add a resource. So I'll come here, I'll go to resource, I'll come back up here, go to resources, and I'll say a data source. Now, there is an omission here, and I have to confess it. The omission is that two of my last projects were using either Snowflake or Azure Microsoft SQL Server. This doesn't show SQL Server as an option. I promise you, it works great. It's about 5 minutes to set it up. I apologize, it's not one of these click start buttons here, but it uses a standard Python driver. It's wicked fast, it scales, it's a great database. So it definitely included. So here's we're talking about user proper database. If you need something that's close to heap data, you've got it. You can use an S3 bucket or anybody else's droplets and buckets. If you want, I'm going to give an opinion. It's an opinion. If you want, I call it sort of low-end web-ish database, MySQL is there. You want something more hardened and open source, Postgres is there. You want something that really scales in his cloud, SAP, Snowflake, and Microsoft SQL. These things are true cloud databases. You put your data into Snowflake or into SAP HANA or into Microsoft, and it is available globally, it's secure, it's hardened, and it's the right thing. And you want to move to that as early as you can in the project. It's not going to run up a big bill. You just want it in there so that later on when your project deploys, you've got that support. Okay, so we just looked at notebooks. I'm trying to go fast here and not slow us down too much. Okay, so I probably just showed this, and that's fine. You do want a database that works in the cloud. That's one of the more important things. And I'll give you an example I've got right now during COVID shutdowns, I've had the problem of being on home networks when I had to deal with some really huge data. Well, if using Zepl notebooks and Snowflake data or Microsoft SQL data or SAP, it's all cloud to cloud. And so your local bandwidth isn't the constraint. If I'm using a bunch of flat files on my laptop, I'm getting killed by slow bandwidth. Here, you've got the scalability, the security, everything. Cloud to cloud is really great. You got all the support you want. You can support Jupyter in notebooks or Zepl in notebooks. Bring them into Zepl, which is sort of an industrial grade notebook that's more cloudified. You can use single sign-on connections with encryption. You can keep your secrets in proper databases. You can code in multiple languages in the same notebook. You don't have to switch notebooks. You can have a single notebook that supports Python, R, Scala, SQL, and everything else. You don't manage the versioning. That's super nice because a lot of teams spend a lot of time managing the versioning. And because of these cloud-based solutions, you can collaborate across your team, and you pay by the drink. You pay as you go, and that with deployment, that becomes very important. Collaboration. Export is the weakest share model you can get. Shoving something to GitHub and having it branch is not a great sharing model. And I'll hop out of here again and hop back into a notebook. And we'll take my super primitive notebook, which I showed you here. Where am I? Here I am. I'm in this one. And you can share it. You share it with somebody, and here's what you can do. You can share it to a specific team. And let's suppose I wanted to share this to Leo, who's one of my data scientists on my team, and I want to add this. Now watch what comes up. Look at all this. You do not get this when you export a notebook or shove it to GitHub in general. Here, this person can have collaboration permissions. You've got all kinds of permissions here. You've got management permissions. You can focus on which versions. This is only got one version, so you're not going to get much versioning here. You can really fine tune the control. For sharing, this is super nice. So you can share with full rewrite between two data scientists, and then share, and this is secret, this is key, you can share to a manager who can see the latest run. So what that means is your manager doesn't even have to have the secrets. You can share it to a business unit, and they can go see your charts and your output and your results from the notebook, but they didn't ever get the secrets. So you're not propagating the secrets to the whole company. This is super important because as these projects become more important inside the company, everyone wants to see it. But the problem with that is you don't want them all to have a copy of the database passwords to get results. With these shared notebooks, you can share a run notebook at basically like a static report, and they can see it. Now, here's a really important problem as you deploy. You've done all your modeling, you've trained some models, you've got it working, and you want to deploy the thing. So you deploy it, and then you have to ask yourself, how often and how do I refresh my trained models? So there's a shocking number of teams that deploy models which have been trained and then find out my results are getting erratic. Well, you need to refresh. They have to leave their production environment, go back to their development environment, retrain, save the training, and shove it into deployment. It's a bad model. Of course, it depends on what your models are. Some data sets don't need much retraining. I gave the example here, and I'll use it again in a minute. If you've trained a model on 100 million images of cats, cats aren't changing very much over time. And so you don't have to retrain the cat image model that much. You may have to occasionally throw in some more pictures of not cats so that you can retrain. But in general, once you've trained 100 million images of cats and given it 100 million images of not cats, you don't have to retrain that model. A lot of business data sets are not as friendly as cat pictures. The data shapes are actually changing. The polynomials that define the data and the forecasting change. You could enter into a period like we are right now with COVID-19, where a heck of a lot of retail data needed to be retrained in the last 90 days. I promise you, people have been going crazy with training. So you don't want to have to exit your production environment to retrain. It'd be nice if you could retrain using the same environment you trained originally without breaking anything. So what we're trying to do is we're trying to emphasize, depending on your data set, it's very painful to have the training separated from deployment. If you stayed in a notebook model and you can scale with it, you can use the notebooks to retrain instead of having to exit your deployment model. So here's an example of models, and I get asked this a lot. In fact, one of my cohorts asked me, please show this because it's pretty important for anybody who is not themselves an applied data scientist. There's probably 50 different kinds of models. We're going to talk about two very quickly. One of them is probability matching models, where you've trained a model to recognize cats. And you throw it 100 million images of cats, you give it another 100 million of images of not cats. You tell it, make sure you can tell a cat from a not cat. It goes off and develops an algorithm, and then you give it 3 pictures. And the first one, the top one is, it says that's a cat with 99.3% probability. Then you give it a blurry image and it says, well, that's got a 94% probability being a cat. Then you take that same image for number 2 and you lose some of the information. You lose some of the head. And it says, well, it's probably a cat with 1/3 probability. If you showed me more of the head, I could tell. It won't tell you that, by the way. For those people who happen to think all of this was invented since the millennium started, the algorithms to do this come from between 1935 and 1965, almost all of them, except for some of the topology modules. Topology had some big breakthroughs between 1991 and 2003, when the last 12 of Thurston's postulates were solved. But the rest of this is built on Fourier transforms, curve fitting. For example, we just recently found some retail data where the very best model for matching data that looked more like this was called Holt-Winters. Dr. Holt's paper was published in 1957. Dr. Winters' papers were published in 1960. It does seasonality very well. So now you're looking at what we deal with in 3 different scenarios all the time in machine learning. The top one, for example, is basically showing you the true data. That is, if you had infinite density of data, if you could get super high sampling data and go back far enough in time, you'd discover it looks like that curve on the top. For those of you who are not familiar with that curve and never owned an oscilloscope, I confess I owned several. If you never owned an oscilloscope, that's a root mean square. That's what power looks like coming out of the wall. And it's super important curve, but your model may not detect that it's that clean. Frequently, if we have what I call secondary sampling or not enough density, we'll throw a machine learning model at it. Instead of telling us, hey, that's root mean square, dude, it does the second thing. It'll basically create a very compound polynomial. It may be adding together 50 polynomials to create a curve. You'll get no insight from it, but you'll get a model that's darn good at forecasting. Then in operations, and this is a data science challenge, in operations, frequently your business rules will tell you to sample a subset that looks like that bottom curve sloping downward, which is just one of the above curves, but only under a very short time domain. It's in the middle of a cyclical period, and it looks like, well, this particular thing is going to 0. It's trending downward. Well, if you applied the proper seasonality to the right algorithms up above, it'll always tell you the right thing. And you'll end up with something that looks like that little arrow vector at the bottom with a probability fuzzy cone around it. That is, it's basically saying, I'm predicting out for 1 week or 2 weeks. Here's the slope of the prediction. And by the way, that slope can be a curve, not a line. And then there's that cone of certainty or cone of probability around it. That's what you're looking for out of this. And you've trained the models to do this. And by the way, I could show you 50 more slides that look kind of like cats and curves. We're not going to do that here. Then once you've got your models trained, first of all, it is not a monolith. Please don't build a monolith. You may have 5 or 6 key modules with different models in them. Every module should do one thing. And the reason is because the frequency and the resources will vary based on the module. So trained models work in collaboration. So you may, for example, have 2 or 3 models that add up to a particular prediction, and they feed back to your ERP system or your e-commerce store. Keep those together as steps, not a block. One reason you want to do that is because some modules may require 128 gigabytes of data and run for half an hour. Other modules may require 2 gigabytes of data and they run 24 hours a day. So that brings up this next thing, which I called wakey wakey. Make sure that you have a cron model that says your data center model is not too one-sized. Make sure you've got every different model. And here I'm going to come back here and I'll hop back to the Zepl environment. And I'm going to stop sharing this. And I'm going to come back here and I'm going to, let me go ahead and come back here to my resources here. And I'll come back here to my Zepl here, and I'll say new notebook. Now look what I can do here. I can pick a size right here, and I've got bigger sizes than this, by the way. This showing, you know, the standard commercial sizes. They're bigger. I can do this, assign an interpreter, and so I get to right size it. And the combination of 2 or 3 things, multiple languages in the same notebook, really nice. Ability to size the notebook for the exact module, really nice. Running on a clock so that it has 0 cost when it's not running, really nice. Those 3 things are the sine qua non of proper scaling and deployment. You want to make sure that you can put your modules together, right size them, wake them when you want, and not pay for them when you're not. And that's part of this proper model of scaling without running just like what I call a one-size-fits-all data center model. Okay, I hope that makes sense. I think those of you who have deployed this stuff do get this. You've lived with this world. By the way, one of the reasons we're holding this event today is because there are very few standard DevOps models for deploying data science. So we're trying to say, here's a model, it works, and it should all be cloud-based. It should use a proper database, stay within a notebook model, get your scale, keep your cost control. So this is about staying in the notebook world. The cloud model is your friend. You get collaboration. Teams can share this. You can share reports. For example, if you had a notebook that looked like the right-hand side here, you can share that with management. They don't have to have secrets. They don't have to have access to the database. They don't have to do anything. They can just see the results of the chart. And while this statement doesn't make people super happy, I think it's really true. Notebooks are the new Excel. It is becoming the standard way we manage data, manipulate data. And of course, the reason we can't do all this in Excel, even cloud Excel, is you can't put the advanced mathematics in there. These notebooks can run really exotic and powerful mathematics. And we have full cycle round trip from data access to modeling, scaling and reporting, retraining the models, all within a single environment. Honestly, I love it. I personally do have several different kinds of local notebooks on my laptop. When I first started working with Zepl, I was using them all the time because I was comfortable with it. After doing this for about a year, I am almost always in the cloud. It's more secure. I get the resources I want. I'm not bound by network traffic. I need just enough traffic to get bits to my browser. That's all I need. The rest of it's cloud to cloud. The data transfers are cloud to cloud. It's changed everything, and it's made it much more enterprise secure and better for collaboration. Okay, so here's what you can do next. First of all, you can go to the question panel. You can ask some questions, and Elise has already sent me some messages. There's already questions that have come in. And the other thing you can do is you can get a free trial. Now, let's step back for a minute and just slow down for just a second because we're almost at the half-hour mark. Let's suppose that your team has been using what I call BI tools, and don't take offense with that. If you've been using BI tools and you need to move to data science tools and you don't know where to start, here's how you start. Go get a free trial for Zepl, send an email to me or to Elise, or just go to the Zepl website, and we'll do this for you. We'll hop on a Zoom session. It'll be open circuit. You can talk and ask questions. You can share your screen, and we'll walk you through how we get jump started. It is really happening. Enterprises are deploying this right now. We have some incredibly important enterprises using Zepl right now to do exactly what we described, and it is not commonly done. We're inventing kind of a new model for cloud to cloud operationalizing and deploying. So my email address is there. You can get a demo. Elise, can you tell me what questions we have? What's the first question?
Sure. What model works the best for highly stochastic data?
Sure. So stochastic data is data that has a fair amount of apparent randomness in it. And my answer is it's always going to take more than one. If you have data with a fair amount of randomness in it, even if there's a steady data pattern, what you want to do is cycle through 5 or 6 models, or in my case, 30. I'm obsessive compulsive. Cycle through a lot of models, find the two, and use them to sanity check each other. That's the best way to deal with a fair amount of randomness inside otherwise organized data. I think that answered the question.
Excellent.
By the way, and you can do that in a single notebook. So for example, let's suppose one of the modules was best done in R and another was best done in Python. You can do them, marry the data frames, and you can do it in a single notebook. So sorry, Elise, what's the next one?
No, that's great. Let's see. Why not use flat files for fast processing?
We do. We certainly use flat files. If you're breaking down the data while you're still modeling it, you use some flat files. What I would urge you to do is, first of all, keep the flat files in a database. So just, single table. If you're using local CSVs for some of the testing, get them off of there as soon as you can, because it's insecure data. It's on someone's laptop, etc. If what you need is performance, let's go back to use a proper database. Use a database that's actually fast in the cloud, and the ones we talked about are, Microsoft SQL in Azure environment, Snowflake, SAP HANA. These things are wicked fast. If you're looking for what I call a dump and scrape database, and you want the equivalent of something that's flat files, my go-to tends to be Amazon Redshift, because it's pre-configured for columnar data, and I use it for my flat files, my scratch files. For my true production data, I'm probably more prone to use something like SAP HANA or Snowflake, just personal bias.
Great.
Next question.
Yep. So it looks like somebody is confessing that, in fact, their team does store their credentials right in their notebooks.
Sure.
So they're asking, you mentioned that Zepl has security around that. Where does Zepl store secrets and passwords?
There is actually a really simple answer, which is just go find a proper database that you want, and I'll give you an example here. There's a couple different examples you can have here. We will store them. For example, you come in here, you pick a notebook, and let's pick my R notebook here. I'm in the wrong one. Let's just go ahead and look at the COVID-19 data we got here. I told you we've been doing some stuff around this. And we'll go with this prediction profit multi-state. By the way, you can see this is here looking at the United States. It's country-based, and it's basically showing the curve for this. So where are the credentials stored? They're right over here. They're right in here. And if you went in here and you basically, even if I open this up, and I can do this safely, even in a live webinar, I can sit here and I can open this up and I can show you, there are my credentials. You do know some secrets. By the way, this isn't very secret, since this is a public marketplace database. It's not like you can't get to it too. But you can see I've got my secrets here. It's actually relatively safe. The only true slightly hidden information I'm giving is the name of the database and my username. That's it. The actual secrets are hidden in here, and I can make this work. And by the way, again, remember, what I can do is I can keep as many secrets as I want in here. Remember, and I promise you, this is so much better than just having a local credentials file, or particularly having the passwords hidden right in your Python code. Thank you very much. Okay, that answered the question, Lisa, I think?
I think so. Let's see. Next question is, you mentioned that Zepl runs in containers. So how many containers can I run at once?
Well, this is the nice thing. So first of all, in most data science, and even deployed operational data science, you're not ever running 10 containers at the same time. You've got a little bit of a trip trigger. It'll run this one, run this one. So you can stagger your cron jobs, and you can run as many as you want. It's cloud. We're not going to run out of cloud for you, I promise. We got tons of back-end resources. If you said, well, I'm going to need to run 100 containers at the same time, we can support you. You'll be a real important customer, but it's supportable and doable. But what you really want to do is you don't want to run containers all the time. You usually want them to run on a clock, and then when they're not running, you're not paying. And that is huge advantage for scalability over the data center model. But there's no real limit. Our cloud service providers are little companies like Amazon Web Services, and so if we need more resources, we got them.
So Grover, is there a, just a follow-on question to that, is there a scheduling capability then in Zepl when you say run them?
Yes, there is a scheduling cron capability right in the notebook manager, which is super nice. It's far better than having an external cron. You've got a cron built right into the notebook. I won't show it right now because it takes a minute or two, but it's built right in. You can run it, and it will load the container. It'll actually start up the container, run the imports and the requirements, reset all of the dependencies, collect the data, and get going. And it'll remember your connections for your databases between, so that even if you're using multiple databases and multiple cloud sources, it'll all wake up, but you're not paying for it when it's not running. So let's suppose you decided, hey, I need a really big container. I need a 64 gigabyte container to run this job. You're only paying for it while it's doing the work, then it goes to sleep.
And then you could do that every day at 2 a.m. or whatever
You can do it once every 4 hours, every day at 2 a.m. It's got all the things you need in cron. You're not going to run out of flexibility for cron, and you can make them as asynchronous as you want, or they can also, by the way, which is one of the things I frequently do, is when I wake my containers up, I wake them up and say, "Am I ready?" And if I'm not ready, right in my code is check to see if I'm ready. Has the last other module completed? If not, just wait. Wait in the container and wait, I might wait 30 minutes and then instead of starting and stopping. But if it's wait 3 hours, it's like, just go back to sleep, end the job, and let the cron wake it up later when it's time again.
Great. Let's see, we have one more question, which is how big can I scale data frames?
Well, first of all, at some point, you do want to go parallel. And, you can support that. We got a lot of support for parallelism. But the real answer is that, you can scale these things. We frequently bring in massive size data. The secret is if you want a really big data frame, you want a big skinny one. What you don't want is huge and wide. That's the general rule in data science. If you need huge and wide, then you need to fraction the files down and fraction up the work. But in general, we scale them. And for example, I can bring in, if you've got, 100 character wide, columns, you can bring in, several gigabytes into a relatively small container. And so you can get all the scale you want on the data frames. And the other thing you can do, which is really nice in our environment, because it is multi-language, you can convert the data frames, for example, from a Python data frame to an R data frame, which I'm sorry, they use asymmetric data frames. You can convert them right in the notebook, and you don't have to leave the notebook and then copy it somewhere else. It's right in the notebook. So we've got really big containers. You saw, in our standard production, it goes up to 64 gigabyte. Bigger is available.
Excellent. Good. Well, thank you to all of our attendees for your time today. Thanks for your awesome questions. Grover, thanks for sharing everything with us. And to our attendees, feel free to reach out to Grover if you'd like at grover@zepl.com or demo@zepl.com. If you'd like some help with getting started with your free trial, we're happy to, as Grover said, walk you through kind of the product and help you get set up with your team and your environment. And have a great rest of your Thursday, everybody. Thank you.
Thanks, everybody. Have a great day.